Measures of position. First one we'll take a look at is a Z-score. Now, this is a standard score. This is a way that allows you to examine two different individuals and compare them in some form. For example, if you have one student in one college algebra class and you have another student in a different college algebra class, and they both take the chapter 1 test, and it's different tests. Well, unless it's exactly the same, probably one's going to be a little bit harder than the other. Hopefully not radically different. So how do you compare them if they're taking different tests? For the ACT, you have two students taking ACT at different times. One's taking it on the 17th of the month, and the next one's taking it on the 24th of the month. How can you compare them? Because they're taking two different tests. The test would not be exactly the same, because if it did, then they could pay somebody to go in and remember one or two problems come out, and they'd have a study guide that if you memorize, or if you could do the study guide and memorize all the different types, you could get a perfect on ACT. So they're different tests, and they're even more than just numbers changed for the same reason. If you had just a same test but just numbers changed, and people could get study guides where they could ace the ACT and go to the top schools in the country, and then ACT wouldn't be worth anything. Well, how you do it is you compare it to who went in with them. For example, the student A went in with a group of people all across the country, and they took the test. So you compare their results, that student's results, with all the people that went in with them. And then student B went in a week later, and they went in with a group of people, and you compare their results to all the people that took it with them. And then that gives you a standardized score of some sort that allows you to compare them. So Z-score, number of standard deviations at a given value is above or below the mean. It says round Z to 2 decimal places. Now our sample Z-score is x minus x bar all over S. Our population Z-score is x minus mu over sigma. You can see that these are basically the same formula. Your data point, x, minus your mean over your standard deviation. Now, if you got any problems asking you if it's ordinary or unusual, ordinary values are between and including -2 and 2, and unusual values are less than -2 and greater than 2. Let's take a look at this example. And let me start a new page. Okay. This says, get my pen to work. There we go. In the 8 o'clock college algebra class, okay, so talking about an 8 o'clock class, it says the mean was 75. Now I'm gonna say mu, even though we could use x bar. Same idea, with a standard deviation of 3, and I'll use sigma since I'm using population values. Bill was in his class and got an 82. So Bill, that'll be our x value. X is equal to 82. Okay, then in 10 o'clock class, it says that on the first test, the mean was 83. So mu over here is 83 with a standard deviation 2. So sigma's 2. And it says Sally was in his class, got 83. And then it says, did Sally or Bill do better relative to their class? Obviously, you can look at it and see Sally got a higher score, but we're looking at in terms of all the people that took it with them. So we're going to calculate the Z-score for each person. So for Bill, we got x minus mu over sigma. Well, x is 82 minus mu, which is 75, all over sigma, which is 3. And what's that give us? 7 over 3, which gives us 2 1/3 or 2.33 rounded 2 decimal places. We'll do the same thing with Sally. Same formula, x minus mu over sigma. So we got 83 minus mu, which is 83, over sigma, which is 2. So that's 0 over 2, or 0. Now Bill's got a higher Z-score, which means Bill did better. Now realize that it could be that even though it looked like Bill did better, the people that are in his class maybe aren't very good at math, so they make him stand out. And for Sally, maybe she was in with some students that did very well in the course, so it made her look worse. So Z-score is not a perfect way to look at scores. If you look at, for example, how they compare standardized test scores, very, very complex statistics there. It's more than just a simple formula like what you're seeing here. So realize that even though you see some flaws with what we're doing here, that in reality they use much better technique. Okay, let's start a new page. Okay, when we get to the next problem. Okay, kth percentile. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. For example, if I was in the 90th percentile, what that would say is my score is better than 90% of the people. If I was in the 50th percentile, then my score is better than 50% of the people. Now, see, it says less than or equal to the value. So you could actually, instead of being better than 90% of the people, you're included in that. But not very often does it actually come out nice. Usually round. So, and it doesn't really much matter anyway. If I said you're in 90th percentile, or if you're in 89.99th percentile, not that you ever use decimals, same thing. Now quartiles. This divides the data into 4 equal parts, and you only have 3 quartiles, Q1, Q2, and Q3. You only need 3 to divide it into 4 equal parts. Deciles divides the data into 10 equal parts. And again, deciles is 10 equal parts, you only need 9 of them. And percentiles, you only need 1 through 99 for percentiles. Now let me demonstrate this with some data. Okay. 21, 33, 57, 81, 102, and 110. Okay. There's, see, I've split it into 4 equal parts. And so Q1 would separate that, Q2 would separate that, and Q3 would separate that. That's why you only need 3 of them to split it up into 4 equal parts. Now here, this demonstrates it not with numbers, but smallest data values over here. Here's Q1, here's Q2, which is also our median. Here's Q3, and then our largest data value. And you can see this says 25% of the data, 25%, 25, 25. Same what I did here. I split them into 4 equal parts. That's what quartiles do. Now this is the steps for finding the quartile by hand. And let me go ahead and break here. Okay. Now finding quartiles by hand. We're going to arrange data in ascending order, determine the median, M, or second quartile, and then divide data sets in halves. The observations below to the left of M and observations above M. First quartile Q1 is the median of the bottom half, and the third quartile Q3 is the median of the top half. Okay, let's look at this example here. And let me do a new 1900, 900. Okay. So we got 33, 37, 43, 51, 62, 65, 72, 83, 91, 105, 110, 201, 305, and 317, 320, and 330. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, I believe. 3, 6, 9, 12, 15, 16. Okay, that looks right. Now, since there's 16, first one says determine the median, M, or second quartile. Well, we got exactly 16, which is even, which means I'm going to average the middle two numbers. 1, 2, 3, 4, 5, 6, 7, 8. So these are my middle two numbers. So the median, or Q2, is going to be the average of those. So we got 83 plus 91 over 2, which is 174 over 2, which is 87, I believe. Yeah, 87. Okay. So then, this says divide data set in half. So observations below M and observations above. Okay, so here's where it's separating the data. So the numbers above this, smaller than it, would be 33, 37, 43, 51, 62, 65, 72, and 83. The ones greater than this would be 91, 105, 110, 201, 305, 317, 320, and 330. It then says Q1 is a median in the bottom half and Q3 is a median in the top half. So do the same thing here. We got 8 numbers, so I'm going to take the middle 2 and I'm going to average them. And that's going to give us Q1. So Q1 is equal to 51 plus 62 divided by 2, which is 113 divided by 2, which gives us 56.5. 56.5. And then we'll do the same thing down here. Since there's an even number of them, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. I'll take the middle 2 again. And Q3 is going to be the average of those numbers. So we've got 201 plus 305 over 2. Okay, which gives us 506 over 2, which gives us 253. Okay, so final answer, Q1 is equal to 56.5, Q2 is equal to 87, Q3 is equal to 253. And those would be our quartiles. Well, you can see some flaws here. I dealt with a very small amount, and they're already sorted. And even then, I'm not sure if I did my basic math right. So there's an easier way, which we'll take a look at. Not by hand. Okay, finding quartiles on a TA3, TA4. We're going to put our numbers in, then we'll make sure we exit out, and then we'll do our stat button, right arrow to calc, enter on one of our stats, and press enter. And then you want down arrow to see the quartiles. So let's take a look at this problem. Excuse me. Okay, so let's input those numbers in. Okay, so I'm going to do stat, enter on edit, and then I got 2, 8, 33, 45, 71, 83, 91, 105, 113, 235, 471, 512, 513, 555, and 1002. Okay, let me do an up arrow and double check everything. Not very good at it, typing in numbers or basic math. 91, 83, 71, 45, 33, 8, and 2. Okay, so I'll exit out, do a second mode. We'll do stat, right arrow to calc, choose one of our stats, and we'll press enter on it. Now see this arrow here, that means there's more down below. So we do our right or down arrow key over and over, and you see that for this problem here, problem number 3, using technology, tells us Q1 is 45. Now Q2 is the same as your median. So on your calculator, I'll eventually get back there. Your calculator says median is 105. So Q2 is 105. Now Q3 was 512. So it gives you all three of those automatically. And you don't have to worry about, well, assuming you typed it incorrectly, no data entry error, you don't have to worry about any basic math errors like I worried about up above. Let me start a new page here. There we go. Okay. Now find the percentile of a number in a list. And the list has to be sorted. We take the number of values less than x, that's the number we're looking for, plus 0.5, divide by the total number of values times 100. So let's take a look at this problem. Number 4, we got 15, 18, 23, 24, 27, 33, 38, 41, 52, 63, 71, 81, 88, 91, and 99. And it says find a percentile of 33. Well, 33 is right here. So that's the number we're looking for. Let's come back up to our formula. Okay, find a percentile of a number in a list. Number of values less than x. Well, there's 5 less than x here. So we got 5 there, plus, tells us to add 0.5, divide by your total number of values. Well, 1, 2, 3, 4, 5, we got 15 total. And then times 100. So we're going to have 5.5 over 15 times 100. Let's see what that is. So I got 5.5 divided by 15 times 100. Enter. And we got 36.7. And you round like normal. So this would be the 37th percentile. When you think about it, 37th, it does look like maybe it's about a little over a third of the way through the data, isn't it? Okay. Now, if you're trying to find the nth percentile, so instead of finding a percentile and a number in a list, you're trying to find 20th percentile or 70th percentile. We're going to use these steps. Let me bring up a problem, and then we'll walk through it with those steps. Okay. So we got 17, 21, 25, 31, 43, 55, 71, 83, 91, 105, 210. I don't know why, but my Alt Tab doesn't like to work sometimes with this package. 210, 233, 301, 315, and 320. Okay, we're trying to find the 25th percentile. So let's go to our steps. Sort the data. Well, this is already sorted from smallest number to largest number. Compute the locator value. Okay, so I is equal to, And it says k over 100 times n. These are a little bit different letters than the book uses, but I like these. K represents what percentile we're trying to find. So we're trying to find 25th percentile, so I put 25 in for K. Over 100 times how many numbers we have? N. Well, there's 15 again. So let's see what that gives us. 25 over 100 times 15. So 25 divided by 100 times 15. And then press enter. And we get 3.75. Okay. If I has no decimals, then you do this. If it has decimals, then you do this. Well, we have decimals, so let's come down here. Percentile says round up, and the answer is is the number at that position in the list. Now, round up means no matter what your decimal is, you always go up to the next whole number. So if this was still 3.01, we would still round up to 4. And this right here tells us what our answer is. This is the fourth position. This is referring to the position. This is the fourth position in the list. Fourth number in the list is 31. So 25th percentile is 31. Let me start a new page and we'll look at another example of that. Okay. So in this one, we got 17, 21, 25, 31, 43, 55, 71, 83, 91, 105, 210, 233, 301, 315, and 320. Okay, we're trying to find the 17th percentile. Okay, so let's go back to our steps. Sort the data. Well, this is already from smallest to largest. Compute our locator value. So we got I is equal to K over 100 times N. Now K is, again, the percentile we're trying to find. We're trying to find the 17th percentile, so we put 17 in for K. Over 100 times N, 315. And let's see what that gives us. So I got 17 divided by 100 times 15. Enter. And we get 2.55. And our steps say if has decimals, round up. So bring it back there. So I is equal to 3. You always round up no matter what your decimals are. So our third, this refers to our position on our list. This says our third number is our answer. The third number here is 25. So 17th percentile will be 25. Now, we didn't have an example of it, but if I has no decimals, like if you came up with 5 or 7, then to find a percentile, you average number in the ith position and the I plus 1th position. Now, let me make up an example so you see what in the world I'm talking about there. Let's say it's a different example here, and I've calculated I is equal to 10. So, these are steps you can't see. So I went through, calculated I. Now, this is referring to, do I got 10 numbers? Yeah, I guess I do. Okay. Average number in the ith position and the I plus 1th position. The ith means you put 10 in for I, so you got to the 10th position. Now I plus 1th position, you put 10 in for I, you got 10 plus 1, that says the 11th position. So if I look at the 10th position and the 11th position, 3, 4, 5, here's the 10th, here's the 11th. So what I'm going to do with those is I'm going to average them. So I got 105 plus 210 divided by 2. Let's see if I can screw up the basic math here. 315 divided by 2, which gives us 157.5, I think. 14, 15, 10, 11. Yeah, 157.5. So this right here would be the value we're trying to find. So that's how you handle it when you have a nice whole number comes out there. Okay. Now, quartiles and percentiles. There's never a by hand formula similar to this for finding the quartiles, first quartile, second quartile, third quartile. The only way you can do it is list the numbers like we did earlier from smallest to largest and find medians. The reason why there is no formula for it is because you can find 25th percentile, which is equal to the first quartile. You can find 50th percentile, which is equal to second quartile, 75th, which is equal to third. So that's built in. So Q1 is equal to P25, Q2 is equal to P50, and Q3 is equal to P75. Now here's some formulas. If you got a problem that asks you to find the interquartile range, the IQR, that's Q3 minus Q1. Semi-interquartile range is Q3 minus Q1, all divided by 2. Mid-quartile is Q3 plus Q1 divided by 2. And the 1090 percentile range is P sub 90 minus P sub 10. Okay, which measure to use? If your shape of your distribution is symmetric, then use the mean for the measure of central tendency. And for how spread out it is, the dispersion, use standard deviation. If your data is skewed left or skewed right, then use the median and the interquartile range. Okay. Now we have outliers. Outliers is an extreme value that could be garbage. Somebody's making up data or data entry recorded it wrong, so forth. You ask at your 10th reunion from high school how many kids people have, and one person puts 200 kids down. Probably it's an outlier. They didn't really have 200 kids, so that skew your results. Outliers oftentimes are discarded just because they're considered garbage data, or data that does not truly represent the rest of the data, so it skews it anyway, even if it is true. Okay, so this is how we're going to check for outliers by using quartiles, and I'll come back to this. Okay, let's work this problem, and I probably should start a new page. There we go. And we got our data. And we're going to use a calculator as much as possible. So first thing I'm going to do is enter all these numbers in the calculator. Okay, so I'm going to go into my stat, go into edit, and I want to clean out that list. So I'm going to up arrow, highlight L1, press clear, and then press enter. And I'll type in each number, pressing enter after each one. So 3.5 enter, 3.2 enter, 4.1 enter, 4.7 enter, 3.8 enter, 5.1 enter, 7.2 enter, 3.9 enter, 5.3 enter, 6.1 enter, 6.2 enter, 3.1 enter, 9.3 enter, 9.4 enter, 10.5 enter, 10.9 enter, 11.1 enter, 11.2 enter, 12.7 enter, 12.8 enter, 13.1 enter, 13.5 enter, 17 enter, 38.6 enter. I'm not very good at data entry, so I'm going to double check myself. 38.6, 17, 13.5, 13.1, 12.8, 12.7, 11.2, 11.1, 10.9, 10.5, 9.4, 9.3, 3.1, 6.2, 6.1, 5.3, 3.9, 7.2, 5.1, 3.8, 4. Save this video. If you ever have trouble sleeping, you can just play it. Okay. Second mode, exit out. Okay. First thing it's asking us for is Z-score. So let's talk about that. Problem 7a. Okay, so wants to know the z-score corresponding to 5.3. So they're telling us that x is 5.3. Now they don't really specify, population data. Never mind, they do. So the formula for the z-score is equal to x minus mu over sigma. So in order to do the z-score, we need mu and sigma, because we've got x, that's 5.3. One very easy way is if you got raw data, you can use your 1var stats. So come over here, I'll do stat, right over to calc, choose 1var stats, and press enter. Now x bar is your mu. X bar is the same as is your sample mean. It's also your population mean. So we got 9.429, 1, 4 sixes, and a 7. Do not round. If you round in the middle of a problem, sometimes it makes significant differences. Over sigma, which is down here, this sigma x, little o with a flip, 7.2426. 7.2426 0.9979. Okay. Now we could type all that in, and if you type in a fraction, if you got more than a single number or a single variable on top and bottom, you have to put parentheses around that part. So when we plug this in, we'll put parentheses around the top part. Another easy way we can do with technology is, since I've done 1var stats, it's in these variables here. So I'm going to do a beginning parentheses, 5.3, minus, and then do vars, choose 5 for statistics, and I want mean, which is 2. Close parentheses, divided by, and then I'm going to go into vars, choose 5 for statistics, and I choose 4 for sigma. And then I'll press enter. And we get negative 0.57. You always run around at 2 decimal places for z-scores. Now you could have typed all this number in and got the same answer. But if you're good with technology and you remember the vars from class, then that's how you find it. Okay, for B, determine quartiles. Well, that's easy. Well, not so easy because we have to do 1var stats again. But if I do stat, right over to calc, do enter on 1var stats, and enter. Your quartiles can be found by doing a down arrow. See the arrow here? You do a down arrow, and it scrolls down. So Q1 is 4.4. Q2 is the same as our median, which is 8.25. And Q3 would be 11.95. After you start typing any kind of value, like we did up here, you can't access that again by doing a down arrow. You have to just reissue the command. Okay, C says compute the IQR, interquartile range. Well, let's go refer to our formula. Now, this is how you check for outliers, by the way. It's guiding you through it. It says determine Q1 and Q3, and then it says find IQR, Q3 minus Q1. So Q3 minus Q1. Q3 was 11.95 minus Q1, which is 4.4, which gives us 7.55. Let me double check myself. 9, yeah. So that'd be our IQR. Okay, now D asks us to outliers or values less than lower fence or greater than upper. Determine the lower and upper fences. Are there any outliers? And again, they're guiding you through it. In order to figure out the outliers, we have to find the lower fence and the upper fence. Now these called different things in different books. Some call it lower boundaries, upper boundaries, but they're used to determine the outliers. Okay, lower fence. It says lower fence is Q1 minus 1.5 Q1 minus 1.5 times IQR, I think. Yeah. So let's find that one first. So Q1 we said was 4.4 minus 1.5 times IQR, which is 7.55. And so come over here, calculator. 4.4 minus 1.5 times 7.55. Enter. And we got negative 6.925. 925. Okay. So our upper fence from our formula will be Q3 plus 1.5 times IQR. So Q3 plus 1.5 times IQR. Q3 was 11.95 plus 1.5 times 7.55. Let's see what that gives us. So let's see. There we go. So let's plug that in the calculator. So I got 11.95 plus 1.5 times 7.55. Enter. And we get 23.275. 23.275. Now this is a range of values. So this is saying that we got negative 6.925 to 23.275. Anything outside of this range is considered an outlier. And that's what it's saying. Outliers are values less than the lower fence or greater than the upper fence. So if we come over here, obviously I don't have any negative values, so we're fine there. But I'm looking for values above 23.275. Looks like just this one, 38.6. So 38.6 will be our outlier. And the lower fence is right here, and the upper fence is right here. Okay, so that gives us our different answers. Now let's talk about the 5-number summary. A 5-number summary consists of your smallest data value, Q1, median, Q3, and your largest data value. Now we've already found some of these. Smallest data value is pretty obvious, smallest number. Largest data value is pretty obvious, largest number. Q1 and median member is Q2 and Q3. We've found these using technology, using TI3, TI4, and by hand. Now, this kind of goes over it, but I'm not going to really cover this. Basically, you do one var stats to get the 5-number summary. So let's take a look at this problem right here. Let's start a new page. There we go. And let's input these into our calculator. So I'm going to do a clear there. I'll go into stat, go into edit, and I'll up arrow and highlight L1 and press clear, and then press enter. So we've got 23, enter, 8, 51, 42, 72, 33, 2, 15, 21, 1 or 13, 117 or 17, 4, 5, 8, 9. Okay, so let me go check that. 9, 8, 5, 4, 17, 13, 21, 15, 2, 33, 72, 42, 51, 8, and 23. I'm going to exit out, do second mode, and all we do is one of our stats again. So nothing exciting. We do stat, calc, and one of our stats, and then press enter. Now you have to down arrow, and the last 5 numbers are your 5-number summary. So I'm going to write that down. We got min is 2. We got Q1, which is 8. Median is 15. Q3 is 33. And max is 72. Now usually they're not written like that. Usually 5-number summary, you just write 2, 8, 15, 33, 72. And that would be your answer for the 5-number summary. Okay, now box plot. This is a graph of a data set that consists of a line extending from the minimum value to the maximum value, and a box with lines drawn at first quartile, the median, and third quartile. Now I'm going to show how to do it with a TI3, TI4, but first let me show the example we just found by hand. They're not difficult by hand, even easier in a calculator. Okay, our largest value is 72. So I want to pick a value that I can easily divide. So let's choose 80. Divide that in half, that's 40. Here's 20. That's 10. And of course this must be 30 then. Halfway between 40 and 80 is 60. Here's 50. And here's 70. Okay, so we're going to draw a vertical line at our minimum value, 2. Doesn't matter how high or how low. Our maximum value is 72, so I'll draw a vertical line there. Now these vertical lines will be a little bit taller than our normal ones. And then there's a line that goes between them. Now we also draw a vertical line, a little smaller one, at our quartiles, at 8, which would be right here, more or less. 15, which would be right here. And 33, which would be more or less right there. And then you draw a box connecting those. Now sometimes they won't actually put the lines inside the box here. It doesn't really matter. What this allows you to do is allows you to see how your data is arranged. If it's symmetric, if it's skewed left, skewed right. And I'll show you some pictures here in a few minutes about it. But see how the data all looks like it's on the left side here? This data is actually skewed right. But anyway, that's how you create a box plot. Okay. Now creating a box plot on a TA3, TA4, put list in L1. You do second Y equals, enter on 1, plot 1, and choose these options. The on, fifth graph, L1, 1. Then you choose zoom stat, and then you press trace to get your values. This will not only give you the box plot, it'll give you the 5-number summary, which we'll see. Here's how you do it by hand. And this even goes further. It talks about something called whiskers. You don't have to worry about the whiskers. If you're doing this by hand, I'm happy with what you saw me draw. And it says mark any outliers with an asterisk. Again, you don't need to worry about that. Let's take a look at this one for the calculator. Well, first thing we got to do is we've got to enter our numbers in. So I go into stat, do enter on edit. Up arrow to L1, press clear, press enter. And I got 18, enter, 2, enter, 33, enter, 81, enter, 3, enter, 5, enter, 7, enter, 12, enter, 17, enter, 13, enter, 15, enter, 55, enter, 72, enter, 8, enter, 3, enter. Okay, let me double check those, even though I was kind of watching them as I was typing them. And I think I screwed up there. That should be a 33. Jeez. 18, 2, 33. Double check the rest again. 81, 3, 5, 7, 12, 17, 13, 15, 55, 72, 8, 3. Now do a second mode, exit out. Now go to Y equals. You want to make sure you don't have anything on Y1. If you got anything on Y1, press your clear to clear it out. Okay. So now I'm going to do a second button and then the Y equals, And we want to go into plot 1. So I do enter on plot 1. And we want to choose on. So my flashing cursor is on the on. I press enter one time. And that changes your highlighting to that. Now, this one isn't too hard to figure out which one. Even though I told you the fifth one, you choose one that looks like a box plot, which is the fifth one. So we're going to press our right arrow key until our flashing cursor is on the one that looks like a box plot, and press enter. Now, these should already be defaulted to L1 and 1. If they're not, down arrow to this line and do second 1 for L1. And then that should be 1. Then we'll choose zoom. We'll up arrow to zoom stat, and then press enter. And then that's your answer. That's your box plot. As you can see from this, looks like all the data is over on the left side, so it's skewed right. Now, if I press trace, notice how it comes up. It says median is 13. If I do my left arrow key, Q1 is 5. Left arrow again gives us median or min is 2. Then if I press my right arrow, is Q1 median. Here's Q3, which is 33, and then our max, which is 81. Was that the value we had before? No, I guess it wasn't. Okay, it's a different problem. Skewed the same way. Very easy way to determine if your data is symmetrical or skewed left or skewed right. It's much easier than trying to draw a histogram, those bar graphs, and connect them together. Now let's see the connection between our bar graphs and our box plots. You see we had this value right here, which was skewed right. Looked like all the data was on the left side. Again, this is the box plot. It looks like all the data is on the left, so it's skewed right. This was our bar graph, our histogram for symmetrical. And you can see more or less most of your data is here in the middle. So that's symmetrical. And over here, looks like all your data is on the right side, and that's skewed left. And again, the box plot looks like all your data is on the right side, and that's skewed left. Now, that's not a real precise way. You know, how close does that be to the middle before you consider it symmetrical? But it definitely shows the extreme cases. And that's the end of that section.